Session on Oracle. Session on Oracle Exadata Administration for Oracle DBS. My name is Muralidhar Punyala. Today our agenda is to understand challenges for mission critical Oracle databases. What is Exadata? What is an engineered system? How Exadata is different? Benefits of Exadata, Exadata versions, Exadata Editions, Exadata Availability, storage server availability, Exadata rack capacity, Exadata scalability. So basically we are going to understand the basic details of Oracle Exadata system, how Exadata system helps you to manage your Oracle database, providing high performance, high availability and scalability, which is required for mission critical Oracle database deployments. So before we understand Oracle Exadata, let us understand the challenges for deploying mission critical databases. As a DBA, you want to deploy a mission critical database. So you need infrastructure. You need to deploy infrastructure, which is highly available and scalable. So you have, in the traditional infrastructure deployment, you have basically two types of challenges that you face to deploy mission critical databases. One is the infrastructure deployment challenges. Second is the performance challenges. So deployment challenges include all the infrastructure. So you want to deploy a suppose you want to deploy a 3-instance Oracle database, a RAG database with 3 instances. So you need infrastructure for this deployment. So basically you need 3 servers, shared storage and network which connects the servers and storage together. So now before you deploy your Oracle databases, this infrastructure should be ready. And in a traditional infrastructure management model, who deploys this infrastructure? So in your organization, you have storage team, you have hardware team, you have network team, you have sysadmin team. So all these teams work together to make this infrastructure available to the DBA. Till these teams prepare the infrastructure, test the infrastructure, and make it available to DBA, you cannot really start deploying your mission critical Oracle databases. So to prepare this infrastructure, to make this infrastructure ready for your Oracle databases, typically it may take weeks to months together, because it is not just assembling all these components. Before you deploy Oracle databases, every component should be thoroughly tested for performance and failures, right? So in this system, there should not be any single point of failure. Okay, so to achieve that level of testing, it takes months together. So your deployment cycle takes longer time. You have to wait for more time. Once the system is ready, then only the DBA can actually proceed with deploying Oracle databases. So these are the typical challenges in traditional infrastructure deployment model. These challenges includes it takes longer time to deploy your mission critical Oracle database, because all the infrastructure has to be configured or tested thoroughly before they hand over to the DBA. Then integration challenges. There are many components in this infrastructure. For example, the hardware may be Dell hardware, the storage may be EMC storage, networking equipment may be Cisco. So all these components are coming from different vendors, which needs to be integrated seamlessly. And because you are integrating different vendor components, you have performance challenge. How to get the maximum performance out of each component, and how to get best performance out of the whole system. That is the challenge. Availability issues. You have to ensure that this infrastructure is available all the time. There should not be any single point of failure. Scalability issues. So how do you ensure that this system scales up with your workload? So there should be a policy, there should be a strategy for scaling up that system as your workload increases. And finally, another problem is multi-vendor support, because you are including many components from different vendors in case of any performance issue. So you have to involve multiple vendors, and multiple vendor support model, you know how it works. So there is always a scope for finger pointing at each other. So your issue remains the same. So these are the typical challenges we see in traditional infrastructure deployment and management model. So for all these things, it takes a lot of time for your infrastructure to be ready before you deploy Oracle databases. Not only this, performance challenges. In the traditional infrastructure that is completely managed by the uh, customer, okay? Today, the database performance is limited by CPU, memory, and network bandwidth. So these are the traditional challenges for your database performance. So in the traditional infrastructure that we deploy and manage, we have less CPU, we have less memory, okay, network bandwidth, and because of this, your databases will not perform at the peak level. You are limited by all these resources. Now, this is where exactly Exadata fits in. So, in this slide, we are going to understand what is Exadata. Exadata is a complete system with servers, storage, network to deploy Oracle databases. So, in one sentence, uh, Exadata is a system that has all the infrastructure required to deploy Oracle databases. So it has servers, it has storage, it has network. So then what is so special about Exadata? Exadata is basically an engineered system which is engineered by Oracle. So what do you mean by an engineered system? An engineered system is one which is architected, which is integrated, which is optimized, which is tested by Oracle. So what does that mean? So customers doesn't need to purchase the servers, integrate the servers, test them for a high availability, scalability. So all this heavy lifting is done by Oracle. So you know Oracle is best team to uh, provide the infrastructure required for Oracle database, because they are the architects of Oracle. They engineered this system. Okay, so customers doesn't need to spend a lot of time to make the infrastructure required for your Oracle database deployment. You just purchase the engineered system and plug it and play it. So this way, your infrastructure deployment cycle reduces, and you get the best system which is architected, which is optimized for Oracle database workloads. And when Oracle engineered this system, Oracle has ensured that this system is highly available. There is no single point of failure within Exadata system, whether it is CPU failure, whether it is memory failure, whether it is server failure, whether it is storage failure, whether it is a network failure. There is no single point of failure inside a Exadata system. That means you can run your Oracle database without any single point of failure inside the database which is affecting your database. Not only that, Exadata is designed as a massively scalable system. So as your workload increases, you can scale up. You can scale up, scale horizontally, and in Exadata, you can scale to virtually unlimited amount. Okay, so that is how Exadata system is designed by Oracle. You can start small and grow big as your workload increases. And Exadata provides highest performance for your Oracle database. So this level of performance you cannot achieve by deploying Oracle databases on the traditional infrastructure. So Exadata uh, provides high availability, scalability, and highest performance for your Oracle databases. The good thing about Exadata is the hardware, the software components, everything is from Oracle. So all the hardware components, all the server, switches, storage, everything is from Oracle, and every software that runs on these components is from Oracle. So that way, hardware and the software, everything is from Oracle. What does that mean to the customer? So if there is any problem, where it is hardware problem or whether it is software problem, you just need to coordinate with Oracle support. So you don't need to involve a multi-vendor and coordinate them to resolve the issue. So everything, anything is taken care by Oracle. So from a management perspective also, it becomes very simple and easy to manage Exadata. Now this slide compares the traditional infrastructure, which is assembled by the customers, the clients, and managed by the clients. And end of the day, this traditional infrastructure has bottlenecks, performance bottlenecks, availability, scalability issues. So you can see on the right side, you have engineered system, which is completely engineered, architected by Oracle engineers. So you just purchase it and plug it and play it, because Exadata is an engineered system. It is latest architecture, latest standards, latest protocols, optimized protocols. So you get best performance out of the Exadata system. So this slide shows you two cars. One is the old style car, which is similar to your traditional infrastructure managed by the customer, and the super fast car, which is like your engineered system. So in comparison, your engineered systems provide best performance for your Oracle databases, high availability and scalability. So if you need high availability, scalability, and highest performance for your Oracle databases, you deploy Exadata. You use Exadata, which is an engineered system. So customers has choice between an engineered system and the traditional system, which is managed by the customer. So you still have the option. So if you don't need high availability, if you don't need scalability, if you don't need performance, you can continue to use your traditional infrastructure, which is which is managed by you, which is managed by the customer. Or if you want high availability, scalability, and performance, you think about Exadata. Okay, so that is the comparison. Now, benefits of Exadata. Exadata provides the following benefits to your Oracle database. Extreme performance. So Exadata, the sole intention behind Exadata is it provides extreme performance to your Oracle database. So Oracle database cannot provide this level of performance on the traditional infrastructure, which is managed by the customer, which is deployed by the customer, which is integrated by the customer. High availability. Exadata provides high availability. As I told you earlier, there is no single point of failure within Exadata system. So you get high availability for your Oracle database. Scalability. Exadata is highly scalable. It can scale up, it can scale horizontally, and it can scale to virtually any limit. That is how Exadata system is designed. So you can start small and grow big, expand the system, scale the system to support your increasing workloads. And the good thing about Exadata is it runs existing applications unchanged. So when you migrate your database to Exadata platform, your database applications doesn't need any code changes, because end of the day, your application uses Oracle database. And in fact, your application gets best performance from your database. So there is no separate testing required. There is no separate certification required for Exadata. If your application uses Oracle databases, your application can use Oracle database running on Exadata platform also without any code changes. So that way your applications can benefit from the Exadata performance. And Exadata runs all types of workloads. OLTP workload, data warehouse workload, analytical workload. And Exadata can be used as a consolidation platform. So you can deploy, you can migrate your legacy databases, hundreds of legacy databases or thousands of legacy databases to a single Exadata rack. So this is another benefit of Exadata. So traditionally, if you want to deploy OLTP systems, you use different systems for OLTP workload. You use different systems for data warehouse workloads. You use different systems for analytical workload. When it comes to Exadata, you don't need different systems. You can use the same Exadata system to deploy all these workloads together on the same rack. And it has features to support OLTP workload, support data warehouse workload, support analytical workload. And because Exadata system has huge capacity, in the later slides you will understand, Exadata comes with hundreds of CPUs, terabytes of memory, petabytes of storage, excellent network. So because of all these things, you can deploy, you can consolidate many databases onto a single Exadata system and get rid of your legacy infrastructure, thus saving the floor space in the data center. And instead of managing hundreds of small servers, you manage a big rack. And at the end of the day, you coordinate with a single vendor for any support related issue, whether it is hardware issue, whether it is software issue, you involve Oracle and you work with Oracle support. So this slide shows you some of the customer experiences that are using Exadata. The intention of this slide is just to give you an idea of how Exadata improves the performance. Okay, and that is the sole intention. So every customer has different experiences, and the idea is just before Exadata, their performance, their system performance, after migrating to Exadata, the system performance. You can see in one of the customer, the workload used to take 37 hours to finish. When they migrated to Exadata, it took 9 hours. And for another customer, you can see they gained 50% by compressing the data and using a feature of Exadata called hybrid columnar compression. So by compressing the data, you can store more data on the same storage. And your backups takes less time because you compress the data and take the backup. Your backup times reduce, your storage requirements reduce. So that way you benefit from the compression. Then another customer, you can see 17 times faster compared to the traditional infrastructure. Another customer, 97% improvement in the query response times. And another customer, which took 20 hours on non-Exadata, took 3 minutes on Exadata. So that way, the idea here is to understand what kind of performance benefits various customers gained, and this without any code changes. So that is very important point here. So out of the box, Exadata provides you highest performance for your Oracle database. Now let us understand the components of Exadata. Exadata system basically includes three components: database servers, which are also called compute nodes; storage servers, which are also called cells; InfiniBand network, which connects servers and storage. So this slide shows you database servers at the top of the diagram. So you have three database servers, and you can have many database servers in the rack. It all depends on the rack configuration. Then at the bottom you have storage servers, which has storage devices, and you have two types of storage devices: hard disk storage and flash storage. So flash storage is your SSD storage. So database servers, storage servers, both are connected with InfiniBand network. And InfiniBand network is the latest networking technology, very high speed networking technology compared to fiber channel networking technology. InfiniBand is 4 times faster. What does that mean? So the data transfers inside Exadata happens at 4 times faster compared to your standard fiber channel networks. So that way Exadata uses database servers, storage servers, and InfiniBand network. On database servers, we install Oracle binaries in the internal storage of the servers and run ASM instances and database instances. On the storage servers, which are managed by ASM, we deploy Oracle databases. So that is how these servers are used. And all these servers, all these components are inside the rack. Okay, so physically you have one rack. So this rack contains the servers, database servers, storage servers, and the InfiniBand networking equipment. Okay, so every component is housed inside this rack. This is the data center rack. It is a standard 42 unit rack. So this slide shows you the rack pictures. So this is how Exadata rack looks like. It is very tall. Okay, you can see the rack being pulled into the data center and being stabilized by this personnel. And you can see the lateral view of the rack here. And this slide shows you the servers arrangement within the rack. So at the top and the bottom, you have storage servers, right? This is standard configuration, of course, whichever I am showing you in this slide, in a standard configuration, and that to full rack configuration. So this slide shows you standard configuration and full rack. So in this case, you will have 14 storage servers, which are arranged at the top and the bottom portions of the rack. So this red, this thing. Then blue one are where database servers are housed. In a full rack machine, you will have 80 database servers, up to 80 database servers. And in the middle, this networking equipment, InfiniBand switches, okay, and equipment, other equipments are housed. So this is how all these servers, all these equipment is housed inside the rack. And this slide shows you one of the server pulled out. All these servers are blades. Okay, so one of the server pulled out. At runtime, you can pull out the blade and you can open the blade. You can see the standard hardware components. So this is how it looks like. Next, let us understand Exadata versions, also called as models. So basically, like any other system, Exadata is available in different versions. So from version 1 to X6. So X6 is the latest and the greatest version. So you have 7 versions or 7 models or 7 generations. These are the terms we use to refer to Exadata. And version 1 was released in year 2008. Then from then onwards, from every year, almost every year, Oracle is releasing a new version of Exadata with some exceptions here and there. So you have 7 versions so far under Exadata, starting from V1, which was released in 2008, V2 in 2009, and the third version, interestingly called as X2. So third version onwards, Oracle changed the nomenclature. So instead of V1, V2 style, Oracle changed it to X. So third version is technically called as X2. Fourth version, X3. Fifth, X4. Sixth, X5. 7, X6. So X6 is the latest. So now the question is, what is the difference between all these versions? So like any system, every version comes with the new features. In case of Exadata, there are 2 types of benefits. One change is in the hardware. Every new version comes with the new hardware, enhanced hardware. Okay, and not only hardware enhancements, every new version comes with new software features. So that way, every new version of Exadata comes with enhanced hardware capacity and new software features. So customers will benefit from both the hardware enhancements and new features of the software. So this slide also shows you the hardware, okay, comparison, different hardwares in different versions. So basically disk storage, flash storage, CPUs, memory, all these hardware details are are shown across various versions. For example, if you take a disk storage, in version 1, Exadata had 168 terabytes of total storage, whereas in version 2, it doubled 336 terabytes. So version 3, 504. Version 4, it remained at 504. In X4, it reached to 672. In X5 also 672. Now in the latest version, which is X6, it is 1344 terabyte. So that way you can see in every version almost the disk capacity is increasing. Then flash storage. So Exadata started using flash storage from V2. What is flash storage? Which is your SSD storage. Flash storage is high performance storage compared to disk storage. So V1 had no flash storage, and V2 onwards Oracle started using flash storage. So today Oracle reached to a stage where the entire storage server comes with flash storage. There is no hard disk based storage. So that type of storage server is also called as extreme flash storage server. So you will learn this in the later part of this slide. So the intention here is to understand the hardware improvements in each version. Apart from these hardware improvements, Oracle makes software level improvements. No new features are added into the software, new algorithms, enhancing the existing algorithms, optimizing the existing algorithms so that customer benefits from both the hardware enhancements and software enhancements. So that is the difference. Now, if you observe the slide, V1 is very different from other versions. That's why V1 is shown in black color, which is different from the other systems. So what is that difference? In version 1, the hardware was from HP, all the servers. Okay, all the hardware is from HP, and the software is from Oracle. So it's like a marriage between Oracle and HP. Because at the time Oracle did not have hardware business, so it had to partner with hardware vendors like HP. So version 1 used HP hardware, HP servers, and Oracle software. Then Oracle acquired Sun Microsystems. So with that acquisition, Oracle got a hardware business. So from version 2 onwards, Oracle started using Sun servers instead of HP servers. So that is the difference. So version 1 had HP hardware, Oracle software. Version 2 onwards, Oracle hardware, Oracle software. So hardware, software, both from Oracle. Now, Exadata Editions. Starting with X2 version, Exadata is available in 2 editions. The edition format is represented like this: X, N, S, where N is the generation number, version number, okay, like X2, X3, X4, X5, X6. S is the number of CPU sockets on database servers. So, for example, if you take the latest version X6, you will have 2 models under X6, X6 to X68. So what is the difference between X2, X62 model and X68 model? Okay, so the 2 and 8, X6, you know, X6 is the version. Then what is 2? What is 8? 2 is the number of CPU sockets on the database servers. 8 is again the number of CPU sockets on the database servers. So in X2 model, X62 model, the database servers comes with 2 CPU sockets. In X6 edition or model, the database servers comes with 8 CPU sockets. Okay, so 8 small database servers are replaced with the 2 big database servers, okay, with more CPU cores and large memory. So this X68 models come with 2 database servers instead of 8 database servers which are there in the X62 full rack models. So 8 database servers, small database servers with a small CPU and a small memory compared to X68. So instead of having small 8 database servers. Oracle ships 2 servers with more CPU, more memory. So these servers come with a larger memory and more CPU cores. So suitable for legacy current applications which are running on large SMP systems that require more memory and more CPU on a single system. So that's why you have more memory and more CPU on x68 models. So for example, you have x62, x68, x52, x58, x42, x48, x32, x38, x22, x28. So starting with x2, every version has 2 editions. 2 socket database server, 8 socket database server. So this slide shows you the difference between x62 model and x68 model. So which is the latest version. X6 is the latest version. Now if you see 2 model, 2 socket. Per socket 22 cores, making 44 CPU cores. Whereas on 8 model, 8 sockets, per socket 18 cores, making a total of 144 CPU cores. So if you purchase X62 model, per server you get, per database server you get 44 CPU cores. Whereas when you purchase X68 model, per database server you get 144 CPUs. Okay, and similarly memory. Okay, the installed memory on X62 database server is 256 GB, which can be upgraded to 786 GB. Whereas on X68 server, database server, the installed memory is 2 terabyte, which can be upgraded to 6 terabytes. So again at memory level also, X68 model excels. It has more memory. And when it comes to number of database servers, X62 model will have more number of database servers. In a full rack machine, you have 8 database servers. Whereas in X68 model, the number of database servers are only 2. Less servers, but more capacity on each server. Here, okay, more servers, but less capacity on each server. So that is the difference. Based on your application requirement, you can choose this model or that model. Now, this slide shows you Exadata availability. If a customer want to purchase Exadata, what is the availability? So Exadata is available in standard and elastic configurations. There are 2 configurations, standard configuration and elastic configuration. Elastic configuration was introduced in X5 version. Before that, we had only standard configuration. So what is the difference between standard configuration and elastic configuration? In standard configuration, the number of servers inside the rack is fixed by Oracle. Whereas in elastic configuration, customers can choose the number of servers inside the rack. So that is the difference. It's like standard configuration is like standard pizza, where everything is fixed by the pizza vendor, right? The toppings, everything. Whereas in elastic configuration, it's like a custom pizza where you can order your toppings, you can choose your toppings. So customer has the full choice. So that is the difference. Now, as I told you before X5, we had only standard configuration. That means before X5, the number of servers inside the rack are fixed by Oracle. Customer does not had any chance there. And again, under standard configuration, there are 4 configurations to suit different requirements of different customers. Okay, so the smallest configuration is called the 8th rack, which was introduced in X3 version. Before 8th rack, before X3 version, there was no 8th rack. Then next to 8th rack, you have quarter rack. Next to quarter rack, you have half rack. And next you have full rack. Full rack is the highest capacity, and 8th rack is the smallest capacity. In between, you have quarter rack and half rack. Now, next to the rack names, you can see the number of database servers, number of storage servers. In 8th rack, you have 2 database servers, 3 storage servers. In quarter rack, you have 2 database servers and 3 storage servers. In half rack, 4 database servers, 7 storage servers. In full rack, 8 database servers and 14 storage servers. So this is fixed. So any customer purchasing full rack across the globe, anywhere, so will get only 8 database servers and 14 storage servers. That is fixed. That is globally fixed, global standard. Any customer purchasing half rack will get 4 database servers, 7 storage servers. Now, if you observe this clearly, 8th rack, quarter rack presents the same number of servers. 2 database servers, 3 storage servers. Then what is the difference between 8th rack and a quarter rack? The difference is not in terms of number of servers, but the capacity. 8th rack is half as powerful as quarter rack. In other words, 8th rack is half the capacity of quarter rack. For example, if quarter rack has 100 CPUs, 8th rack will have half of that, that is 50 CPUs. Similarly, if quarter rack has 100 terabytes of memory, 8th rack will have half of that, that is 50 terabytes. Just for example purpose, these are not the correct numbers, 100 terabytes or 100 CPUs. So I hope you understand this. So these are the standard configurations. Now standard configurations are available and elastic configurations also available. In elastic configuration, customer has the full choice. Customers can choose how many database servers they want, how many storage servers they want, depending on their specific business requirements. Now, when you choose elastic configuration, there are some rules. In a rack, minimum 2 database servers, maximum 19 database servers. And similarly, 3 storage servers, minimum 3 storage servers, maximum 18 storage servers. So as long as you are sticking to these boundaries, you are respecting these boundaries, you can order your own number of database servers, your own number of storage servers. For example, a customer wants 10 database servers, 10 storage servers. This is not available in standard configuration. So customer has to go for elastic configuration. Another example is a customer wants 5 database servers and 10 storage servers. This is not available in standard. So customer has to go with elastic configuration. So that is the difference between standard configuration and elastic configuration. And a customer can start small, okay, with the less budget, less price. To test the waters, you can purchase the beginning configuration, the entry level configuration, which is 8th rack. Now you tested, you are satisfied with Exadata performance, you want to you want to have more capacity. So from 8th rack, you can upgrade to quarter rack, and from quarter rack you can upgrade to full rack. From quarter rack you can upgrade to half rack. From half rack you can upgrade to full rack. So this upgrade is within the rack, okay, within the rack. So Oracle can arrange more servers inside the rack and upgrade your system. Once a full rack is full, you want more, then you cannot upgrade within the rack. You have to purchase another rack and interconnect multiple racks and form something called multi-rack configuration. So that way you can purchase multiple racks, interconnect them with a single InfiniBand cable and form multi-rack capacity and scale up to any amount required. So that way Exadata is highly scalable system. Now, sometimes customers run out of storage very quickly because as you load more data into the database, as database size grows, you quickly run out of storage. So in that case, customers can purchase storage server and add it to the rack. If at all you want to purchase a storage server, again storage server is available in 2 configurations. One is high capacity storage server and second is extreme flash storage server. What is the difference? High capacity storage server presents both the hard disk based storage and the flash storage. It comes with both types of storage. You know, flash storage is high performance storage, SSD storage, compared to your hard disk storage. And this slide also shows you the capacity details on the latest version, X62 version. So if you purchase a high capacity storage server, it comes with 96 terabytes of hard disk storage, 12.8 terabytes of flash storage. This is per server. Then similarly, extreme flash storage server. In extreme flash storage server, there is no hard disk storage. You will get only flash storage. Entire storage is flash storage, which is high performance storage. That means your entire database sits on flash. You get extreme performance because flash is high performance storage compared to hard disk storage. So if you want extreme performance for your IO and the database, you go with extreme flash storage server. If you want a more storage capacity and optimized flash, you go with high capacity storage server. So below that, we have storage servers, which are showing this difference. So on the left side, you have high capacity storage server, which has a hard disk device and a flash device. On the right side, you have extreme flash storage server, which has only flash devices. Now, this slide shows you the rack capacity, Exadata rack capacity in the latest model, X62 model. Of course, this is elastic model. So in elastic model, in your full rack, you will get up to 1196 CPUs spread across database servers and storage servers, up to 17 terabyte memory, and up to 460 terabyte of flash storage, and up to 1.7 petabytes of hard disk storage. So you can see the capacity details of an Exadata single rack. So like that, you can purchase multiple racks, interconnect them, and form multi-rack configuration. So you can imagine the kind of resources you get on Exadata. So with all these resources, high amount of CPU, memory, flash, storage, your databases performs at the peak level. They provide you highest performance. Not only just hardware capacity, Exadata uses intelligent software, intelligent algorithms, intelligent protocols, which contribute towards your performance. And inside the rack, as I told you, InfiniBand network is used. So, which is used to connect servers together and servers and storage together. And InfiniBand is latest networking technology. As of now, InfiniBand is mainly used in high performance computing environments, not very common in commercial computing environments. On Exadata, Oracle started InfiniBand way back from 2008 itself. And compared to the fiber channel networking technology, which is the standard in many data centers, InfiniBand is 4 times faster. So what does that mean is the data transfers inside Exadata happens at 4 times faster compared to your fiber channel networks. So this is the session. I hope you enjoyed this session. Thank you for joining today.